All right, factoring review. I really love factoring, okay? Between factoring and trigonometry, those are probably my two favorite topics in mathematics, okay? So if I seem fairly excited about it, it's because it's a genuine excitement, okay? All right, we're going to start off with basic factoring. Greatest common factor and simple trinomials, okay? Greatest common factor and simple trinomials. When you're factoring a polynomial, it means you're expressing it as a product of two polynomials. So this times that, right? Two things being multiplied together, all right? First method we're going to go over is factoring polynomials with a common monomial factor, okay? The greatest common factor. So we're going to factor using the GCF. Got it? All right. Do we remember GCF? Yeah. A little bit. So the GCF between two numbers is the largest number, right? Not just any number, but the largest number that evenly divides into those two numbers. Yes, bringing some bells from middle school. Okay. Now, from Algebra 1, variables. When there are variables, the GCF is the smallest number of that variable, right? So if I have x squared and x to the third, my GCF is what? X squared, because it's the smallest. Yes? Ringing some bells? Yeah. Hopefully, fingers crossed. All right, let's dive in. Okay, first one we have 15m squared minus 9. Okay, when you're finding the GCF, you start with your numbers. So looking at 15 and 9, what is the numerical GCF? 3. Perfect. Okay, m squared. This is a binomial, which means that there are two terms being added or subtracted. In order to have a common factor, both terms have to have that variable. Do both terms have that variable? No. So do I have a variable GCF? No. So this is my only GCF. Do we see it? Okay. Next, we're going to divide by the GCF. So we're going to divide each term by 3. What is 15 divided by 3? 9. Perfect. What is negative 9 divided by 3? Bam. This is called our quotient. Why is it called our quotient? Because what did we just do? We divide. It's the result of division. Okay? Your final answer is, yes? What is the biggest number that divides evenly into 15 and 9? Okay, so when we rewrite this, it's written as your GCF times your quotient. Okay, what was our GCF? 3. What was our quotient? Bam, you just factored using GCF. Okay, to check yourself, anyone wants to guess, how would you check yourself? Distribute. You check yourself by distributing. Okay, so let's do distribution out loud. Ready? 3 times 5m squared. 3 times negative 3. Is that what we started off with? So what does that mean? We did it right. So every time you ask me, Miss, did I do this right? What am I going to tell you to do? Distribute. Okay, you can check yourself. There's no reason why you should get these type of problems wrong. Because guess what you can do? You can check yourself. Before, if you don't feel good, like, ooh, I think I messed up, distribute. Okay. All right. 60 seconds. 5x squared plus 10x. So if you look at your notes, notice I took away the steps from you, right? Because it should feel a little natural. If you need to write the steps out, 1, 2, 3. Keep going if you need to. I don't know what happened to my 3 on the rewrite. This is 1, 2, 1. That says 1, 2, 3. Please tell me this feels like a review. Yes. Yeah? Yeah, a little bit. But if not a review, it'd be easy to catch on. Yeah. Okay. We don't have to keep talking about one. I know. It was remote learning year. Who knows what y'all did? Oh, oh, yeah, that year was. Well, for the whole year, we have no. I'm sorry. But we didn't have. Go. And now we get to fix it. All right. Who wants to tell me the GCF? 5 what? 5x. Why is it 5x? Exactly. Both terms this time had it at least what? 1x, right? Okay. Now we're going to divide by 5x. 5 divided by 5 is 1. X squared divided by x is x. Remember, when you're dividing exponents, you're subtracting their powers. What's 2 minus 1? 1x, right? 10 divided by 5 is? And x divided by x is 1. Okay? So when I rewrite this, I can get rid of those friendly ones, right? Are they necessary? No. So my GCF was perfect. And again, if I did not feel confident, what did I need to do? Check with distribution. Because you probably found the common factor, but not the greatest common factor, which I don't know what you would have done. Did you just do 5 and not 5x? Yeah. That's why. You found the common factor, not the greatest. Okay? Yes. Now, another thing is that you know that you found the greatest if these two terms have nothing in common remaining. Okay? So they have nothing left in common. X and 2 have nothing in common. So I know that I found the greatest. Does that make sense? All right. Let's try again. Here you go. 4x to the 5th minus 6x cubed plus 14x. For all of them? Yeah. Greatest common factor. This time we have a trinomial. So all 3 terms you're looking at. You're looking at the numbers and at the variables. As you are working, if you are stumped, if you need me, whistle, put up wave a white flag, put up thumbs, tap your desk, call me. What about this song? Oh, me. Okay, so I know this is right. Oh, I forgot. Do you remember powers? Powers is the powers when you're finding the exponents. What is parentheses? Yeah, power rule. It's not a big fine, but someone drew on the wall, I cut it because of. So this is 5 minus 1 and and x. This you said parentheses. This is multiplication from there. See, I thought you meant the power of. Oh, here. There's no the parentheses disappeared. Are you good? Okay, you don't need me? Cool. All right, how we feeling? Okay. Okay, what's my GCF? 2x. Okay. Each number is divisible by 2, and my smallest common variable is x. Yes? Yeah. All right. So once we divide, the first term, what did we get? Perfect. Then perfect. Perfect. All right. This is my GCF. Is it my factored form? No. My factored form would be 2x times 2x to the 4 minus 3x squared plus 7. And again, if I wanted to check myself, what do I need to do? Distribute. And when I distribute, I should go back to being that, right? How we feel? All right, let's bring it up a notch. Let's take it up a notch. All right, on 4. This is an example when your leading term is negative. When your leading term is negative, your GCF is going to also be negative. Got it? My leading term is negative, so my GCF is also negative. Yes? All right, go.
Oh, wow.
Do variable by variable. No. How many A's do they have in common? A's they have in common.
1, like 5.
How many B's do they have in common? How many C's do they have in common? There we go. Why'd you give up?
Wait, what?
No. What? We're so dramatic.
-4.
Because you're going to divide out the negative. All the variables that you need. So every variable they have. Okay. How many A's do they have in common? They both have A squared.
Oh, no. Right.
Okay. How many B's do they have in common?
B.
And how many C's do they have in common?
1 minus 1.
There you go.
B.
All right, as you finish 4, just feel free to keep on 5 and 6. 5 and 6. I don't know why I said frisky. I don't know. I do not. You're not cats. I know y'all aren't cats. For CP line, cat. No. I just keep thinking myself. What's my GCF, peeps? ABC. There we go. Okay. So I'm dividing this by -4 ABC squared, dividing this by -4 ABC squared. A negative divided by a negative is a positive. So my 8th grade teacher is forever like in my brain. I just remember every time I think about this, I see her. A negative and a negative makes a positive. A negative and a negative makes a positive. Like I'm seeing her with her little fingers. Now, yeah, she's just really, well, I know I'm not gonna describe her. Never mind. Yes, I know what she looks like. I don't know how to describe her PC, so I'm just gonna keep going. Politically correct, so I'm just gonna... Nice, polite. All right, here we go. A negative by a negative, so that gives us 4, not 4, 2. I can divide. That's why you're supposed to be telling me what to write, guys. Y'all leave me out here on my own. -8 divided by -4 is 2. A squared divided by A. B divided by B. 1. 1. C squared divided by C squared. 1. -12 divided by -4. A negative and a negative is a positive. So it's a +3. A negative times a negative and a negative divided by a negative is going to always be a positive. A divided by A. What happens to C squared divided by C squared? It becomes 1, goes away. So our final answer should be -4 ABC squared times 2A plus 3B. Almost. ABC squared. It's not your mama's ABC anymore. All right. Yes. Okay. Do we need a little more practice or are we feeling it? We're good? Okay. Well, the first one. All right. Last one we're going to do. We'll leave 6 for you. we have 3x to the 4 minus 9x to the third y plus 6x squared y squared. Find my GCF, find the quotient, write the factored form. Because your a squared, this one doesn't have to be, you don't have one. So you're still not what they have in common. So it's yeah, how many of that letter does it have in common? So this has a squared, this has one, but in common they only have one a. This has b and this has b squared, but in common they only have one. Here, b squared, because they both have squared, that is common that. Exactly. So like on this one, what do they have in common? So they each have x's, and how many x's they have in common? Remember when I asked out loud, if I have x squared and x to the 4, what is their greatest common factor and what is their least? I agree. She said x squared. The reason being is that because even though this one had an x to the 4, this one had x squared, and so they have 2 in common. One has 2 more, but in common they both have at least 2. Does that make sense? Like, for you, let me draw this. Okay, so if you're visually struggling with the variables, this is basically saying you have 3x minus 9x. Please let me do this first. Plus 6x y. You're looking for what do they have in common? So when I'm looking for what they have in common, well, 3 divides into all 3 of these. Agreed? And then this one, I have one x, I have an x, I have an x. I have an x, I have an x, I have an x. Do I have any more x's in common? So then therefore we had how many x's? 2, x squared. Okay, this one doesn't have a y, even though these two, but does this one have a y? No. So therefore, my greatest common factor is 3x squared. Okay, so then when I divide each one of these by 3x squared, I'm going to have 3 divided by 3 is 1. X to the 4th divided by x squared is x squared. Negative 9 divided by 3 is negative 3. X cubed divided by x squared is x. Y had no friend. 6 divided by 3 is x squared divided by x squared is 1. The Casper goes away. And y squared had no friend. Okay, so therefore my factored form is 3x squared times x squared minus 3xy plus 2y squared. Okay. All right. So if it helps you, if you're a visual learner, sometimes breaking it down. I'm gonna leave you to do 6 as a challenge. Check yourself, check with the peer, and let me know how it goes. All right, at the bottom of your page, I want you to write, if a polynomial cannot be factored, it is called a prime. So basically you're saying if it cannot be factored, it is a prime. What this means is that your GCF equals 1. So if the only thing they have in common is 1, which is what everyone has in common, then it is called a prime. Okay? Prime. Prime.
Trying to be different.
No. Okay, or you may see in Algebra 1, you probably learned as not factorable or something like that. Does that ring any bells? Not factorable, non-factorable. All right, so if we have something up here and they had no terms in common, we would have just written prime. Got it? Well, that's when you're talking about numbers in general, your prime and your composite numbers. Yes, because composite numbers are made up of more than one multiple factor. Hold on. All right, next part. So we're gonna go on to notes of trinomials, okay? Pretend that there's an I here. Okay, that I went bad, but it's in there. On your paper is correct though. That's what matters. Okay. It also still applies. If a trinomial doesn't work, if this factoring doesn't work, guess what it's still called? A prime. Okay. Prime means that any polynomial, not just what we just did, can't be factored. Okay. So here it says a quadratic trinomial in standard form. Do we remember ax squared plus bx plus c? Yeah, ax squared plus bx plus c. This is our quadratic form function, right? Our whole little parabola friend, right? He's back. Okay. Here's our quadratic. Your a term is always with your x squared. Your b coefficient is always with your x, and your c is always going to be your constant, right? Your number. Solo. Got it? Yes. All right. So this is important to remember where everything is. Okay. We're going to talk about factoring trinomials. Okay. The reason why we factor trinomials or polynomials in general is usually to find an x-intercept, a solution, right? So we're going to start off with what's called visually branches, but ultimately you end up doing it mentally. Okay. So branches works like this. You're asking yourself what multiplies to give me 12, my C term, but adds to give me my coefficient of my B term. Okay. I hope so. We're getting there. So my C term is what in this problem? 12. What are the factors of 12? What multiplies to give me 12? 1 and 12, 2 and 6, and 3 and 4. Okay. Out of these options, what adds to give me 7? 3 and 4. So my magic numbers that make this true, I wrote a 7 and not a 3. Do we remember? Yes, yes. Whew. Okay. 3 times 4 is? Yes. 12. 3 plus 4 is 7. Okay. The reason why I don't do that initially is because you guys don't know where those numbers come from, which is why I make you list out your factors. Okay. It's reverse. So I'm doing it. Yeah. Okay. So therefore, my factors are a positive 3 and a positive 4. So my binomial factors are b plus 3 times b plus 4. Okay. And how do we check this? FOIL. Exactly. We check using handy dandy FOIL. Okay. FOIL is asking first times first. What is your first term times your first term? B squared. Outside times outside. What is b times 4? Inside times inside. And last term times last term. And when I simplify, do I come back to where I started? So that tells me that I did it correct. If I do not go back to where I started, that means I messed up on my factors. Yes? Okay, so step 1 is to list out our factors of our C. Step 2 is to determine which one adds up to be the coefficient of our B, right? Got it? Step 1, we start here. Step 2. Are you ready to do it? It is. It's all right. Here we go. Here's yours. T squared plus 12t plus 35. This is why it's so important. Don't do that. So important to know your multiplication charts.
I know. I was stressing out.
35 does not have that many factors, though. 7 and 5. 35. What are y'all doing? Why are y'all freaking out? All these dramatic responses. I was nice. I started us off slow. Where are you trying to go? All right, ready? What is my constant? What's my C?
35.
35. So step 1 is asking what multiplies to give me 35. What multiplies to give me 35? We have 7 and 1 and 35. Are there any other factors? No. Out of these options, what adds to give me 12? 7 and 5. So 7 times 5 is 35. 7 plus 5 is 12. So my factors are t plus 7 and t plus 5. Does it matter which one you put first? No, it does not. And if I didn't feel confident, what would I need to do? Just FOIL. Yeah?
Yes.
Yes?
Yes.
We're good? No one's like, ah, I'm going crazy. Okay. All right. Last one. What? Z squared plus 5z minus 24. So this time your C is what? Negative. What are the factors of negative 24? Subtracting is the same thing as adding a negative.
Oh, negative 83.
So negative 83, that's a factor possibility. Okay. What are your factors for negative 24?
So we're gonna be using one process.
In this case, you have to, right?
Yeah, yeah.
Yeah. Yeah, we're good. Feel a little better about it?
I think they might be having
You start before we start. We don't relate. So.
But then I do what you see like that. When you see.
Okay. What is that? Guys, like, oh man, finishing. Oh my gosh, I remember.
As you're finishing on your assignment page, there's a reflection moment. We're gonna start thinking about how we feel. Okay? You said the same thing twice, by the way. All right, on your 3.5B assignment, there's a reflection moment, and I would like for you to take a moment as you finish this. Write down something you feel good about. Write down something you feel like you probably still need to work on. Everything. Where do we write that out? Yes, I just don't make remember that. Does that make sense? Because as long as you pick the right factors, it will work. Yes. All right. What are my factors? What do we get? Good one, good one. We got what? Positive 8 and negative 3. Now, there was a bunch here, wasn't there? You had a lot of options for this one. You had like 8 options, right? And out of the 8, this guy was the winner because 8 times negative 3 is negative 24 and 8 plus negative 3 is positive 5. Okay. And again, if I couldn't do it, what do I need to do? FOIL. Okay. So as I was walking around, as I told you before, part 3 is going to be your what? Do now, tomorrow. Tomorrow, I love you. All right. Okay, tomorrow's due now. You're going to combine both part 1 and part 2. Find the GCF and then factor. Find the GCF, then factor. Okay. All right. Now, I also told you as I was walking around for you to write down something you felt confident about, something you still needed to work on. Okay. So on your paper, you should have written down on your assignment page at the top where it says reflection, something you felt confident about and something you still need to work on. Okay. We're going to take maybe a quick 30 seconds for you to share with someone at your table something you feel confident on. It's okay.
With my variable. What did you write?
Okay. Class, not class. We learned nothing of that. We learned nothing. We did not. All right, we did our 30 seconds. All right, now, I passed you out a bingo board. We're gonna be playing bingo roughly the last 5 minutes of class this week, okay? What you are playing